Next, we will be moving in to the very first keynote speech of our conference, which will be delivered by Professor Prasad Vimalaratna, Head of the Department of Communication and Media Technologies of UCSC, on the topic, Role of Metaphors in Information Visualization. I would like to invite Professor Vimalaratna on stage for the keynote.
Hi, good evening. So in this talk, I will be talking about the role of metaphors in information visualization, because all of us tend to use metaphors in day-to-day life when you use a mobile phone or a computer, but maybe we didn't consciously think about, what this thing is really, what this really thing called metaphors, and also we'll see how this will help us to reduce the cognitive load and deal with unknown things in a more easier and user-friendlier manner. So during the talk, I'll try to take you through the journey of some of the fundamentals of what is a metaphor, and then we'll go into two-dimensional metaphors, three-dimensional metaphors, and also I'll be talking about some of the projects carried out at UCSC in different domains, like when you want to have large sets of data, can you do visualization in a more intuitive manner in 3 dimensions, and also software source code, like source code visualization. So in other words, software cities will be one of the examples. So this is the agenda actually. So we'll be looking at briefly the concept of metaphors and also 2D and 3D. And we'll be looking at 2 case studies referring to some of the work done here, security-related case study, software cities, and also source code evolution. When it comes to metaphors, how we can use metaphors to visualize source code evolution. So those are 2 of the case studies. And also I'll refer to some other work done by another university, because metaphors can be used in different contexts, in linguistics, in 2 dimension, in 3 dimension. The last example I just want to quickly look at is controlling an unmanned aerial vehicle using the concept of metaphor. So it can be applied in different domains, although it originally started from linguistic domain. At the end, we'll be concluding with some other active research directions, and also with some concluding remarks. So when you talk about 3D metaphoric information visualization, what we try to do is to visualize abstract data and information using something called as spatial metaphors. So here I'm using the word metaphor to define metaphoric information visualization, but don't worry, when it comes to the subsequent slides, we'll look at what exactly is a metaphor. So what happens actually here is, we try to take the advantage of people's knowledge of real world to convey a concept or a model using your previous knowledge. Say for example, if you take your desktop, Windows desktop, we are used to desktop in day-to-day life. So we have a similar mapping in your Windows desktop. But if you look at the desktop, we are using multiple metaphors there. The mapping from real world. We have a trash can there, or recycle bin. In real world, we tend to use unnoted paper into the trash can. And then we have mapped that as a metaphor into the desktop as a recycle bin. So what we do is, we put unnoted file into the trash can. So there's a similarity. In linguistics, we talk about analogies and metaphors, but we use the same concept, you will see as we go. Because as I said earlier, metaphors can take variety of forms, because it can be linguistic nature, it can be in 3 dimension, you'll find different metaphors, and also you will find metaphors in 2 dimension, and you will see wide variety of metaphors used in the real world. If you look at the hardware domain, we have memory. So memory is again a metaphor used in a different context, because memory can remember things. So if you take hardware memory, it does the same thing. So the concept of metaphor is everywhere when it comes to computing, But here the talk is focusing on graphical or visual metaphors in particular, and we'll see different application domains and how this can make our life easier in different applications. See a similarity, like say if you take the trash can, we can have a picture of an icon of a trash can. So a person who will see the trash can will tend to identify or recognize this would do something similar to the waste bin that we see in the real world. So a person who will invent a metaphor has to think a lot about the cognition and see how people tend to do things in real world. I will show some analogies as we go. So if you just take this example, let's spend a couple of minutes and see a couple of seconds, I would say, and see what does it trying to, it's a metaphor, it's a visual metaphor. What is it trying to convey? If you look at the left, a famous diagram actually, the left-hand side. So what it's trying to say is, so through a metaphor we are conveying, so we have the devices used for cultivation, and we have one-to-one mapping of the fork and the knife. But if you look at the right-hand side, it again gives a very strong message through a metaphor. So it's the shape of a ship, but we can see it looks actually it takes the same form of a spade. So in the left-hand side, use spades, not the ships. So don't import food, try to grow your own food. This is a timely topic, I guess. It's a nice illustration of a visual metaphor. So that's why I said, when you invent a metaphor, that has to be really, it's not that straightforward, but there are a lot of thinking behind inventing metaphors. This is another nice example I found on the web. I put the URL here. It gives a very strong message about smoking. It's a metaphoric representation or illustration of the message you want to convey. We can see the smoke around the neck. It gives a strong message. When you smoke, what happens? So likewise, you will find different forms of metaphors. Even if you take a desktop or if you take paintbrush, we have rubber stamp, eraser, pencil, all sort of real world things that are mapped one-to-one. So people who see the interface, a little child who will interact with your interface doesn't have to read a manual. Probably she or he will figure out, okay, this is for this is for drawing, this is for erasing, etc. So that's the intuition. So when you talk about metaphoric information visualization, we deal with visualizing abstract data and information with the support of visual metaphors, like what you have just seen with the illustrations from 2D actually. So what we do here is we use users' prior experience to help them to interact with the computing system in a natural and intuitive manner. So that's the basic philosophy behind that. So when you take the familiar UI metaphors, I'm just having a UI desktop here. So you can see we have, in a real world, we have various devices or various pencils, pens, clocks, etc. So in your desktop also we can have similar icons which will represent as a metaphoric representation. Here we have a rubber stamp and magic wand and various keyboard, etc. So a person will realize, okay, there's one-to-one mapping. But if you take your media player, we have a fast forward eject button which you are familiar with real world for playing a video. So when you see the media player, he will figure out, okay, this is for pause, this is for eject, etc. So let's look at a couple of examples very quickly. So this is what I was referring to earlier, the two-dimensional metaphor, the trash can, which we are all familiar. So it can be represented in different pictorial representations. So we can just discard the things that we don't want there. And a carousel. Carousel is something that we see in the merry-go-round. When you're kids, we have merry-go-rounds where we spin around the carousel. So same concept has been adopted in the web interfaces. So we have the mobile phone, you can just, slide your photographs. So it's the same carousel. So we call them as a carousel because it's mapped from the concept of a real world carousels, whether it's a desktop application or a mobile application, we have the same concept there. So if you look at our own website, we have many metaphors there already. We have the menu, which is the restaurant menu, right? So it's a 2D example of a metaphor. And the carousel, we have the slider, the photograph slider is a carousel in the website. So it's a 2D interface where we are able to flip around photographs. So there's a window and it rotates. That's the mapping we are using there. Breadcrumbs. When you browse through the web page, we want to see where we are, the situational awareness. So we are at home initially, then we went to level 2, level 3, level 4, etc. So as you click on the links, we should know where we are. So we are using the concept of breadcrumbs, but actually breadcrumbs come from this fairy tale where this particular character uses a trail to come back home because he can find the way back home. So carousel, breadcrumbs, again uses a real world metaphor from a fairy tale. We can see the same concept being used. So in the web pages also we see. So these are all two-dimensional metaphors. So far we have looked at two-dimensional metaphors. But if you take another probably most widely used metaphor is the 2D desktop metaphor. So we have the real world desktop on one side, on left hand side, and we have the Windows desktop or the Linux desktop or Apple desktop on the other side. Just to save time, I think I have quite a bit of slides, so I will do a bit of flipping. So I think with that, you may have an idea like, okay, we encounter a lot of metaphors in day-to-day life, whether we use a web interface or whether we use a mobile phone or whether we use a desktop or whatever. But when it comes from 2D to 3D, we can do similar things in 3D as well. That is the focus of my speech. A three-dimensional interactive data visualization using metaphoric approach. That's the theme of our talk here. So when it comes to three-dimensional metaphors, we have seen in our website a two-dimensional carousel. We can have a three-dimensional version as well, which may not be very intuitive, but that's one example. And another common metaphor we use in three-dimensional is the pencil. So the tip of the pencil can represent one aspect, height of the pencil can be another aspect, the color of the pencil can represent another metric, or the eraser can represent the color of the eraser, can represent another metric, etc. So you can map real world parameters or matrices in your metaphor based on how you want to apply that in the three-dimensional world. And the other example would be the room metaphor. So when you come to the room, we have walls, pictures, furniture, and various artifacts inside the room. So we can map that into a room metaphor. I will show an example later called CodeCity, software cities. So when you have a code base of a couple of 100,000 code, we can visualize that as a large city, which will represent code as buildings and land and various aspects there. And another example here. So when you invent metaphors, we always think about the real world artifacts. So we have onion. So if you cut onion and peel it, there's a certain fashion. So you can drill down from inner layer to the outer layer. So we can map that into a context when you want to do information visualization. So when it comes to three-dimensional interactive metaphoric visualization, we have a wide variety of already established concept which can be extended and fused, and you can do much more things than what is already existing. So we have a lot of other examples, tree metaphor. So we have different districts. Each tree can represent different aspects. It can be COVID statistics or election results or whatever. And mushroom, I'll show how we use this metaphor in our case study, which we have used for COVID data visualization. On top of that, there are other metaphors also, lightning metaphor, flower metaphor, likewise, the list goes on. So there are lots of real world metaphors that we can use when it comes to three-dimensional information visualization. So if you look at the process of bringing this into three-dimensional interactive visualization, there are certain phases that we have to go through, like mapping of the information, properly visualizing it, and having a mechanism to navigate through the representation. So we can't just bring that as it is. So we have to go through certain phases, and then come up with certain methods and mechanisms and models to support so that the user can do something useful with the data, and also managing dynamics. So if you have live video streams or live data you have to update, so we have to look at the dynamics as well. So there are 4 aspects that you will have to look into. So if you look at some of the projects that were done at UCS in recent times, I can show you how we have adapted and attempted to bring something better than what is existing. To start with, if you look at the contemporary dashboards for COVID-19 visualization, I have the most popular or most widely used dashboards, one on WHO dashboard, and the other one is the Johns Hopkins University dashboard, and this is how they look like. So we have all the information you want, but this is how it's typically presented. You can find any statistics there. Our own dashboard, if you look at today, this is how it would look like. Similar to WHO, Johns Hopkins, this is what we see. We need to find out information or see different patterns and trends and what we have to figure out. We can do, but this is how it's available. So this is today's data. You will see on the web on our own. So the question is, can you do something different so that the user will be able to find what he wants in a more intuitive manner, rather than going through 2-dimensional charts and radial charts and bar charts and etc. Look at how the world will look like. And we are using a pencil metaphor to represent each country. So the data about each country is represented by a single pencil. So the height of the pencil will mean something, that the color of the tip will mean another parameter, color of the eraser will mean something else, so likewise. So once you select a country, say Sri Lanka, if the country has district divisions, so we can represent another method. And when you want to go to city level from district level, we are using that carousel which we see in 2 dimensions. Traditional approach, but we have used that in 3-dimensional carousel, which is a 1-to-1 mapping, obviously from 2D to 3D. And then from city to PHI ward, if you take Colombo city, each PHI has a ward he's looking after. So when you want to drill down onto that level, we are using a different metaphor. We can of course try to use the same metaphor, but that may not be the best. So based on what you want to do, we can analyze and try to see what would be the best metaphor that will suit that particular level of analysis. So for that, we have used the tree metaphor. And then once you drill down to the last level, we go into the traditional radial charts, bar chart, pie charts, etc. Tree level data, if you look at the district level data, we take the longitude, latitude, altitude. But when you go to the PHI ward, say Colombo 7, the University of Colombo region will be looked after by 1 PHI. There's something called a PHI ward. So that's the territory there. So from world to country, country to district, district to city, city to PHI ward. That's what we have tried, but we can go into much more different levels based on what you want to do. So this is how it works. This is our attempt. Actually, we can improve, but we found a lot of things through this. So we have the world level. So this green and red means certain things. I will explain that later. So each country will be represented by 1 pencil. So there's a pencil representation for Sri Lanka. Once you click on that, we can flip into the map view, where we will be using mushrooms for each district. So the color of the mushroom, height of the mushroom, and the size of the stalk will mean something. I will explain what this pink and red and yellow means in a moment. But when you want to go into a particular, the next level, so we're using the carousel, but we have seen the website with carousel photo gallery. Photo galleries use carousel, but here we are using a 3-dimensional carousel where we can start with, let's say, male-female distribution, and then recoveries, hospitalizations, whatever. So we can cluster them like what you have seen in the 2-dimensional interface of the Sri Lankan dashboard. So if you want to go to the final level of detail, we can go into the traditional 2D details where you can go into the actual data. But the path from here to there, and you want to roll back, drill down, you can do that in a very interactive manner. So you can, roll back, drill down, operations can be done in an interactive manner. So you can try to find what they want. So the idea is to see whether compared to two-dimensional interface that is out there, can you do something more intuitive so user can find and get the information they want, or decision makers, all the stakeholders. So similarly, we can go into PHI ward level. You can see a picture. So male female distribution versus the age group, 1 to 20, 20 to 30, whatever. So we can parameterize them and map them the way we want. So the metaphor of pencil has certain attributes here. The way it's mapped is the height of the pencil is the total cases. So if there's a tall pencil, that means there are a lot of cases reported in that country. And the yellow segment on the top, which is the eraser, will represent the number of patients in the hospital. So that may not be analogous to one-to-one as a pencil, but at a glance, we are able to find out what's going on there. And the green segment, that's the middle part of the pencil, will represent the number of recoveries. So out of the whole lot, how many people will recover? And the red segment, the tip of the pencil, will represent the number of deaths. So the size and the length of these parameters are shown as visual parameters. So we are able to intuitively look at, okay, this is how Sri Lanka look like. So likewise. And here in this case, we used the mushroom, a single mushroom for each district actually. So the stalk length will represent the total number of patients in each district. So that you can see some of them are tall and big, some of them are small, and the cap size are number of recovery. So we have mapped the number of recovers in the cap size, and the color, yellow means there are no deaths, but the intensity of the color become more red and whatever, like a spectrum from pink to whatever. So that will give you the intensity of death rate actually. So by looking at that, okay, you can see a particular district look really red, but there are less number of cases. Another district, a lot of cases, but less death. So likewise. So we can feed the data coming from a source like Johns Hopkins or our own database, and then we are able to visualize, interactively navigate, and then find the information we want. So this is how it look like. So from pencil to mushroom, mushroom to carousel to tree, as I said earlier, and we can represent the legend. And also this is about Anuradhapura district in our data set. So we have done some pre-processing from Sri Lankan data set and connected to, got the data from Johns Hopkins as well. We tried out various cases. So we can see over this about Anuradhapura district, the age, gender, status, and duration. And if you get the status, you can classify the way you want, whether child, adult, elders, etc. And you can go to more lower level granularity based on your requirement. So once you go to the PHI ward level, we use the tree metaphor, deaths versus hospitalization, gender versus age versus state, etc. So leaves of the tree are mapped to the pie chart, so we can drill down from one level to another. So you click on that, you go to next level. If you want to go back, you can revert all back and go forward. So as for the case study, these are some of the things we have mapped actually, because we have non-dimensional data as well as dimensional data. Non-dimensional data include ward name, longitude, latitude kind of numbers. They don't have any dimensionality. But if you take main dimensions, gender, age, status, and gender, of course, male, female, you have to map that with the properties of the metaphor that we are using, whether it's a mushroom or a carousel or tree or whatever. So age, we can again get the distribution from the data set and then cluster them and get the user to drill down and do whatever he wants. So this is how it looks like actually. So you can see here world level to district level to Colombo ward map. So this is a one instance of the mapping actually. So that was actually the Bambalapiti award from the Google map, and so can drill down and see the deaths versus hospitalization at given point in time. So we can start with one parameter and then drill down and see through the path you want to investigate. So once you go to the lowest level, of course, we have this is from a popular tool actually. We have radial charts, pie charts, bar graph, all sort of charting we can do. So at the last level, we can use the standard charts that are out there for what you want to analyze. But in our case, we have used simple bar charts and pie charts, etc. in the last level. So this is a quick overview of the actual video. Let me take the folder and try to play that video. Yeah, hopefully it should run. Yeah. It's a quick snapshot of what I just mentioned. So your total cases, total deaths, and total recoveries, you can select what you want to visualize. Once you do that, you can start drilling down. So it's a prototype built for the purpose of doing an evaluation. So it's for Sri Lanka. We want to go to country level. So from world level to country level, we are going to Sri Lanka. And you can see there's a mushroom representing each district, Polonnaruwa, Kurunegala, Kandy, etc. And then we have the color represent, and there's a higher death rate, we have more red there. So once you click on the mushroom, we get different subdimensions, gender, status, age, etc. And then the periods, the duration of. So we can interactively explore. Once you go to the lowest level, of course, we can use all these radial charts, bar charts, etc., and then get the information you want in an interactive manner. So you can go forward and go backward. So this is a simple example of attempt to bring some of the metaphoric concept into a visualization of a data set. So this can be applied to finance data, weather data, anything. So we use a data set as a case study just to experiment and see the level of intuition, etc. The next example would be more interesting, I would guess, because when you say software, we are used to text, piece of text when you say software, but can we visualize them as a city, software city? So that's an interesting metaphor, which is established, but we have gone beyond the standard concept of city metaphor. I'll show you how we have done that, because we know the time we spent in reading the code versus writing the code is like 1 to 10. So we spend more time in reading the code, understanding others' code, fixing bugs and improving things, etc. So there's a need to visualize and understand the code better. So the question here is, can we consider software cities? Because we have a desktop, we had a carousel, we had a breadcrumb. So likewise, can we software city? So that's the question here. Yes, it's possible. The metaphor CodeCity allows us to visualize software as cities. So we have class level, package level information, and the matrices, lines of code will represent the height of the building, right? So source code will look like what we have on the left-hand side, it's all text. But when you get that into the three-dimensional environment, is a city, districts, and buildings, etc. Metaphor, but it can just visualize, that's all it can do. But we want to experiment in a next level in a security related case study and also code evolution. So if you look at the basic code metaphor, so we have the concept of city, and city has buildings and districts. So we have packages and classes. So we have classes here, and then we have packages, and buildings will represent And matrices can be mapped the way we want to visualize different aspects. So if you say height of a building will represent the number of lines of code for that particular chunk. So a taller building means there are a lot of code there. So likewise. So classes are represented as buildings in the city, while the packages are represented as districts that they will sit there. So so we can see here the real world city versus the code city. Now what we have done here is we wanted to visualize security vulnerabilities in the code, because when you have a large code base, finding security vulnerabilities is a difficult thing. So what we've done is we scan the security vulnerabilities, not everything, take the top 10, because if you look at the site like OWASP, we know there are top 10 vulnerabilities as of today that the list get updated. So we want to narrow down the scope by listing down the top 10 or top 5, and we can narrow down that, because otherwise if you have hundreds of them, then it doesn't make sense. So you get the most worst ones and then try to visualize how. So we can see here, we get the source code, the CodeCity, and then we fused that with security vulnerabilities, and we were able to visualize the vulnerabilities in different part of the code. So you can see there's a big code, but there are a lot of vulnerabilities from top 10. So once you go into a building, we went further from there. We brought the room metaphor. We know if you take a room, we have different artifacts there. So inside the walls of the building, so if you go inside the building, in the wall, it can represent different aspects of security vulnerabilities. And also on the floor, like our chairs and tables, we can put different, like a bar chart, 3-dimensional bar chart. Of course, we can do a lot of experiments here and bring more and more intuition. So if you think about this versus running a tool like SonarQube and getting a lot of hundreds of vulnerabilities and a large code base, it'll be very difficult. So open source code base was tried out with this, and there were things we could learn from there. And also there's another attempt by one of the students to look at the source code evolution, because we have different versions of software. Can we visualize different versions? So I have analogy here. Eiffel Tower being built at different levels, different versions of that. So similar things can be done, time traveling, back in time and forward can be visualized. So that's another example of using a metaphor. City software visualization so visualize software as cities basically, but we can go beyond that, not the basic metaphor. This is another project from another research group. It's about the code ownership of contributions at different developers. So we have a team of 10 people developing the code. We can visualize the contribution made by different developers using different color segments. So if you take a particular building block, we can see large contribution by X, smaller contribution by Y, etc. So this again can be useful, because if they are in textual form, getting this information is very difficult. But if you get into 3D, with intuition, you can see it will help the person who want to analyze this information to reach that in a more intuitive and efficient manner. I wanted to show something different, because we said we started linguistics and then we went to 2D, then we talked about 3D, and then we went to different contexts. Now let's look at some example from another research group doing something very interesting. I found, I thought it would be interesting to see. Let me play that video as well. It will take like a few minutes, but I think it's worth looking at. So you can see he's using the mobile phone gesture, but as a metaphor to control the UAV. He's taking the first person view of the UAV and controlling with the gestures. So once you create, combine or fuse such metaphors, the user will be able to view them, navigate them, explore them. 3D can be a very useful method to approach. There are many challenges here. Actually, this is a very active research area, so there are different directions, but I listed a couple of for you the gravity of certain things people work on if you have to push the boundaries further. So one challenging part would be mapping the concept to the data and information in an intuitive manner. Because if you do the wrong mapping, what would happen? So there are some concept I'm familiar in the real world, and the designer has mapped that in a wrong manner, so that can easily confuse the user. So that's going to be worse than what we can do in the ordinary manner, right? So one of the challenges is to think about the intuition and how people think actually. So I think I can take something beyond this discussion. Has never seen the door handle like that tend to pull it. But when you have a knob type door handle, the person who has never seen or experienced that tend to rotate it. So that's intuition. So as a designer, the shape of the handle can be done in such a way that they don't tend to. But imagine that as a designer, you don't think about the intuition. You design some, really nice looking door handle, and people will break the door actually, because they tend to do the other way around. I'm sure you have experience in day-to-day life. There are some, some mapping that is done in incorrect manner. So as a user, there's a usability issue. Same usability issues comes into software interfaces as well. So one of the challenges is to come up with correct mapping, and intuitive mapping is one area. And the other thing is whether we want to drill down and roll up type of operations cannot be done sometimes with a single metaphor. So you have to work with multiple metaphors. So how to fuse them, and also the underlying driving mechanism. So in our example, underneath, so we can roll back and down things. But how do we get that dynamic behavior? And also the fusion of metaphors. What metaphor has to be selected? How we are going to the metaphoric information with for real-time visualization of dynamic and complex data. When I say dynamic and complex data, we talk about data in motion, streaming data that will enable decisions within fractions of a second. And data at scale, petabytes or exabyte of large data, again, is a challenging area. And data in many forms. We talk about data lakes, for example, structured, unstructured, text, multimedia as one pool of data. So when it comes to deal with them, that's going to be very tough. And also better comprehension and analysis of large volumes of dynamic and abstract data, again, going with that, it's going to be challenging. So likewise, there are a long list of challenges that yet to be pushed as boundaries. These are some of the areas that I want to just highlight when you look at the state of the art. So as a summary, because we started with the metaphor, we can say metaphor is by definition is inexact. So it's a great term. Say metaphor, we know it's a mapping, it's like analogy. So if you look at the fork and the knife example, we know by looking at what it is, right? So it's trying to convey the message. If you take that smoke and the man with the cigarette, again, it gives a strong message, very clear, very intuitive. But how we do that is something very interesting we can see here. So metaphor is interpreted as contextually at many levels, from a single individual to a large culture, everything in between. Say, for example, as Sri Lankans, we may be familiar with one concept, but if you bring that concept into a web interface, in a different culture, they will have a different meaning, because we know color has a meaning. Red in China China has one meaning for red and Japan has another meaning for red. If you take white, in one part of the world is death and mourning, and other part of the world is, purity and, different meaning. So if you look at the web interfaces, color has a meaning in different cultures. So likewise, metaphor, again, we can come into universal metaphors. Like if you look at the shopping trolley we see in e-commerce systems. In initial days, if you look at 2D metaphors, they used to have this basket for British e-commerce sites, because in Britain it's more widely used at the time, not now, the shopping basket. But whereas trolley was an American thing, but today trolley is universal, so everybody knows shopping trolley is for putting stuff in trolley and then going to the checkout and buy that. So like even waste can, in initial days of interface, in Thailand kind of country, they use more cane. So they use the icon of cane, woven basket for the trash can, whereas others use plastic looking. So people will figure out, because we are familiar in our culture, this is the trash can. So likewise, with the web, today most things are universal. So there are a lot of things. So likewise, there are some points I wanted to highlight in conclusion. Whether it's 2D or whether it's 3D, there are certain things that are common actually. So in conclusion, so it's an active research area in large data visualization. With big data, the metaphoric approach to interactive data visualization can do a lot. So there are a lot of things that can be done when it comes to large data visualization. So we have looked at 2 case studies, one software cities, other one is pulling out data, the pandemic data. So data can be anything, it can be weather data, it can be education related data or financial data. Getting to support the data analyst in their tasks and communication of insights to the naive end users is something that is necessary when you deal with large data sets. So creating intuitive interfaces is still a challenge and yet to be addressed. There are many things when it comes to 3D as well. With that, I will conclude my presentations and we can have Q&A or discussion. If you have any questions, Shani, how do you take questions? Yeah, okay. Any questions or anything, any feedback or questions?
Sir, you have discussed that color.
Kasun, yes, Kasun.
I'm here.
I can hear you. Yes.
Yeah. Color has different meaning in different countries. For example, in Chinese culture, red is considered as a good color.
Yeah.
So let's assume that we are developing a website that need to be used in multiple countries, different cultures. So what is your recommendation on how we can localize?
Good question, Kasun. In the early days of developing web, for example, corporate websites, I don't want to call names here, but let's say computer company X, they had Japanese version, Singaporean version, European version. You have to map the metaphors. I can tell you a nice example, a particular gesture in the icon. In one culture, that's a rude gesture. In the other culture, that's quite fine. If you take some of the vehicles, you see, I have one particular example, I don't want to quote here the exact detail, but the name of the vehicle, if you look at, okay, European vehicle has a different name, but Japanese same vehicle has a different name. Because in Europe, that particular word for some reason is a rude word or whatever, so they can't use that name in the vehicle, so it was named, I'm talking about 1980s vehicle, a Jeep actually. So likewise, Kasun, I think what happened in initial days is to have different versions. So if you say .jp, it comes with a different look and feel. That is one thing we can do. Because getting universal e-commerce, yes, we are able to do it today, because if you go to eBay and all, it's all one world with the internet. But if you have, I can take one more example, Kasun, 2 more examples if time permits, Tushani. Yeah, One is there's this e-commerce site selling wine, and they were selling wine all over the world. And then Japanese customer tend to ask the question, "Where's the other bottle?" They were query, customer query is coming, "Where's my other bottle?" Then they investigated, and then they found in the Japanese culture, when they package things, they don't leave empty cartons. So if you buy 2 bottles, let's say 3 bottles, you have a package for 3 bottles. I think Heva can correct me if I'm wrong, because it's been there for many years, right? So that particular example in e-commerce. But in the other Europe, for example, they have a standard for 4 carton this thing. So if you buy 3 bottles, you put and then send the whole thing. But in one country, that is not normal. Same thing with baby canned food. That's a very interesting case study. They were selling canned baby food. This hens type. Not hens. I'm telling with canned baby food. They were selling canned baby food through an e-commerce site. And in one part of the world, I don't want to quote the country, but no sales basically. They tried out and no sales, but they realized in their culture, in the food containers, they have a picture of the food. But that particular company, baby canned food, they have a picture of baby, so they don't want that. Not that they misunderstood, but they don't, they are not receptive to that. Hasan? So we had to design whether it's a UA metaphor or a food container or whatever. So cultural awareness, I would say it's different versions, Kasun.
Okay, thank you, sir.
Yeah, whether it's a vehicle example, I will tell you after the talk, the name of the vehicle and what happened. Even web icons, I have seen some example that just says root in one country, so we can't have icon for that. So we have to be, have to have different versions.
Thank you for the detailed answer.
Okay. Hope I answered you, Kasun.
Yes.
Okay.